Hey, welcome back, Ben again. Today we're taking a look at how to train a custom object detection model for Tensorflow 2. So we're going to do this in two different ways. We're going to do it with Google Colab, and we're also going to be able to do it on our local PC. So I'll put up some timestamps somewhere over here, and also in the chapters below, if you want to skip ahead to just see one. But first, there are some common steps between both of them, so we're going to do those first, and then we'll split off into the two separate versions. If you've never used Google Colab before, it's an online tool which uses Jupyter notebooks or Python notebooks, and you can use free GPUs and CPUs online, and it's really great for model training because if you don't have an NVIDIA GPU like me, you can make training go way faster, and you can also run it in the background and not use your system resources. So again, we'll be going over both of those. Let's go. Okay, so before we get started, just to let you know, if you haven't been following, I have two previous videos that are actually on this topic for TensorFlow 2. In the first video, we installed and set up TensorFlow, and the second video, we showed how to detect on videos. So if you want to follow along with those two, I recommend looking at those two first, since we're going to be using the same environment for a lot of the setup, but otherwise, feel free to follow along anyways. So the project I'm in right now is actually just a copy of the same one we've been using in the two previous videos. Same thing with my Conda environment. I'm just using a copy, and that's just in case because that's just how I like to do it. I like to make copies when I do like another tutorial, but otherwise for your case you could be doing this in the same directory that you made for the other ones. So the first thing we need to do is collect images, because we need to make a model, and to make a model you need to train something, or you need to look at something, because otherwise there's no model to be have. So I'm going to make a model on Legos because I like Legos. So I've already collected a bunch of pictures, and I'll show you some of them here. I've just downloaded a whole bunch, and you can see we just have a picture of some bricks. I just wanted to do 3 different colors of the 2x4 bricks. So you'll see I have a whole bunch and some different colors. You can scroll through these, whole bunch. So it's a good idea to have like 200 or more pictures, because the more pictures you can provide as training data, the better your model is going to be. And I'll give you a warning right now that my model is not going to work that well. Just because I don't have that many pictures, and I'm not going to be training it that long just for the purposes of this tutorial. But if you were to do it with your own objects that you wanted to train on, get as many pictures as you can. And the general rule of thumb is that about 80% of the pictures you have are going to be kept in a train folder, and 20% of them are going to be put in a test folder. So here, let me grab mine. This is another just kind of prep that I have. I'm going to copy in the ones that I have already into this project here. And you know what, I'm actually going to put this into an images folder. That'll help us keep it a little more contained. Images, and I'm just going to put these back in here. Okay, nice. Oh, and it was so nice and opened all these pictures for us. Okay. We can close those. Don't need that. Okay, cool. So now we have an images folder with our test images and our train images. So you'll also see that there's some XML files in here, and that's because I've already skipped a step. So what we're going to do is that we're going to use a tool to annotate all of our images, because we need to tell the training, like, hey, in this picture, this object is right here. So to do that, we're going to use something called label image. And so to download that, we're just going to do pip install label image. Just like that. And it looks like I already have a copy of it. So then to run it, you can just run label image, and we should get this nice window. So what we're going to do is that we're going to open the directory that our images are in. Again, you might have yours in a different place, and I already have mine sorted out. But if we're going to go into train per se, we're going to select this folder, and you can see that we start to get our images in here. I also recommend changing the save directory over here because otherwise you're going to have to verify every time where you want it to save. So again, I'm just going to have it save in the same place. So we're reading from from train. We're reading from train and we're going to save in train. So now we need to annotate each one. And to do that, you can either on this left here click create rect box, or if you press W, that'll automatically bring it up for you. So all we got to do is click and drag to our bounds, just like that. And I'm going to call this one blue_brick, like that, because this is a blue brick. You can label these however you want, but that's just how I choose to do mine. And then do Control S for save, and you can actually see down here, we downloaded an XML. Nice. So now if you can either do next image or previous image, you can also use the A and W key, so D, forward, backwards, and you can see all of these are actually labeled already because it's pulling in the old annotation data already did. But you're going to do the same thing we did for the first one. We're going to do W, select and drag, and add. So you can see this one's a red brick, and I labeled it as red. This one's green, and we'll get to one that has multiple. Yeah, so like this. So if you have multiple of the same object, you can just keep creating more boxes and label them all as blue. If you have different colors or different objects, you can also put them in the same one. I should have an example of that. Yeah, so this is a red brick, and this was a blue brick, and you can see we have both in one image. Cool. So that's the gist of that, and you'll see that we're going through this file list, and you can keep creating them. So go through all of these until you've annotated them all, and do this for both your test and your train images. You need to do it for both. Close that, so you'll see in my test, the one that has the fewer amount of images, you'll see that I still have the XML for those too. And for train, you'll see they all have the XMLs, and I'm actually going to delete that extra XML. I actually don't see where it is, so maybe I won't. We're just going to leave that in there. I'm sure that'll be fine. Okay, cool. So now we need to have these XML files actually converted into CSV files, as that's the format that the TensorFlow wants it in. So I'm going to bring over another script I have, and all this data and scripts I'm going to be using today are also going to be on my GitHub repo, which I will be sharing in the description. So I'm going to paste this in here. And I just have a script called XML to CSV. And as you can tell, it's going to take XML files and convert them to CSV files, which is pretty easy. So this is going to look for a folder named images that has the folders test and train underneath it, which is why I put it in that top level images. So I'm going to, down here, I'm going to make sure we're in the right directory, which is models, research, object detection. All right. And now we're just going to say Python, XML to CSV. And there we go. And if we look inside of here, yep, you can see it's updated. And now we have test labels, CSV, and train labels, CSV. Nice. So that part's pretty easy. All right. Next script we need, let me close this, is a generate TF record. This is kind of like the training file we're going to need. So let me pull open a copy of that too. Again, this one will also be in the repo from which you can download. Paste. Okay. Now, for your purposes or for your model, you will have to edit this file. This file has this class text to int. And what this is that this is where your labels come back and play. So you'll see if row label equals blue brick, it's a 1. If it's red brick, it equals 2. So for you, if you were saying training on like macaroni, or maybe like different types of pasta, maybe you had like macaroni and like shells and spaghetti. In here, you could have like shells is 1, or like penne is 2, something like that. It's pretty straightforward. Just make sure you're using the same labels that you used in your training. because it's going to look for these names. So if you remember, I specifically said blue_brick. So this is going to match up with this. It's going to find the text. The order here doesn't relate to the XML or the label image that we use, just as long as you have them all here. In our next step, when we do the label map, the order will matter. But for right here, just add these. If you have more labels than me, you can just add another line right here. If you do another row label equals, maybe we had a yellow brick. Whoops. And then you would just return the next number. So in our case, that would be 4, just like that. And if you had less, then you just get rid of it. So if you only had 2, just 1 and 2. But in my case, this is already set up for my model. So we're going to have 3, just like that. Nothing else in here you should have to change, sorry. So now we're going to run the script, and you can see I actually left in the commands we need to use. So the command is Python generate TF record, and then you have to pass in the input for those CSV files we made. And we're going to do this twice, one for the train and one for the test. So this one, it gets it for the test labels, the image directory of where those images are, and then we create an output, which is going to be a new file, which is test.record, and same thing for train. So I'm going to copy this, paste it down here, and we're going to run. It might take a moment. Again, you might need to edit the command if your paths are a little different, but if you're doing this along with me, these paths should be fine. So it looks like this finished, and if we go down here, yep, you can see a new file down here, test.record, so that's great. And now we're going to copy this one, which is for the train. Enter that, and that should run. All right. If I refresh over here, yep, now we have test.record and train.record. Awesome. Cool. Next step is that we have to download a pre-made model to train our model. So it's kind of like using the work someone's already done and piggybacking off of that, which is kind of how all new models are really made. Because if you had to start from the very beginning, you would have to relearn how to even detect what an image is, if that makes sense. So if we can just start from using a different model, it makes our life a lot easier. So we're going to go to the TensorFlow model zoo, which we've been to before in our other videos. So in here, we can pick a model that we want to use. And so in this column, there's kind of like how fast the model is compared to its relative performance. And you can pick a different one if you like. I'm going to use this efficient det one right here. And whenever you pick one, we're going to right click on it and copy the link address, just like that. And we're going to go back. And we're going to use the same file that we've used in our previous tutorials, which is our model downloader. And we're going to do the same exact thing that we've done before. We're going to put our link in here. And we're going to update this tar file to be the name. Just like that. Just like that. We have our 2 names in there. So now we're just going to run this model downloader. You can either run this from the command line or depending on your IDE, I'm just going to run it from there. And it might take a minute. No such file. Oh no. I wondered if it even downloaded it. Let's check it out. Okay, so it did download. Maybe I copied it wrong. Let's copy the name of this. We're just going to copy the file name. Yeah, looks like I was missing a letter. Let's run it. It might try to download it twice now, but we'll see. Okay, there we go. Yeah, so I downloaded another zip or a GZ, which is fine. But now we should also have this folder up here. So you can see one of my old models right here, the faster RCNN. But now we also have our new one, which is the efficient det. Very nice. Okay, now that we have this model, we need to update some config files that we're going to use. So we need to go to our object detection folder, which we're already in. We're going to go to, where is it? Config, sorry. And then we're using TF2, so we're going to go to TF2. And then we're going to find our config file in here. So we're using the efficient det d0. So we're looking for that. Oh, there it is. Here's ours. I'm going to make a copy of this. And I'm going to put it under where we've been putting our stuff. So one layer up. And we should get this nice looking config file. So there's a number of things we have to change in here. So the first thing we're going to change is the number of classes. And so right here you can see that this model originally had 90 different classes in it. In our case, we only have 3 because we have the 3 different Lego bricks. So again, change this depending on what you have. So if you have less, if you have more, just make sure that this number is the same as that. Now we have to change the fine-tune checkpoint, which kind of tells it where to start training from. So you can see right here, it actually has a path to be configured right here. So in this case, we're going to use our new models checkpoint. So if we go to that folder we had, the efficient det, the new model we downloaded, if we go to the checkpoint folder, we want the path to this right here, this checkpoint 0, because you can see there's a checkpoint 0 right here too. So we're going to use this one. So we're going to copy the path to it. Which path do I want? We'll get the content root one. We'll paste it in there. Okay. And when you're putting your path in here, make sure that all the slashes are forward slashes and not backslashes. Otherwise, you may get an error about something with truncating. If you're seeing that error, either try A, changing your path to be the absolute path, so like where it starts at like C and then like users and then blah, 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 and or make sure that these slashes here are facing to the right, like that. Nice. So now we're going to change the fine-tune checkpoint type to detection. And now we're going to change the input path down here. Input path right here. Okay. Lots of things to look at. So under this input path, this needs to go to our train record. And we're going to do the same for the test one that's in here too. So for the train input reader, the input path should be to that train.record we made, which is right here. So I'm also going to copy the content root. And we're going to put that in here. And then for the test, it's actually going to go in here where it's eval input reader. So it's a little bit of a different name, but this is the one for test. We're going to copy the content root. Oops, too far. Put that in there and test.record. Okay, cool. So now we're going to come back down here in a sec, but one more thing we want to change is this batch size right here. So if this is kind of how intensive and how much resources you can use on your system at once, specifically with the number of images I believe it can look at once. So if you have an NVIDIA GPU or a CUDA core enabled GPU, you can make this number higher, but if you do not have one of those GPUs like me, you need to set this lower as it's going to be using your CPU and it'll be using your system memory. So I recommend going as low as you can first. So I'm going to put a 2 there because I've done this before when it's even at like 8 and it will completely like freeze your computer more or less because it uses all your memory and all your CPU at once. And that's not a good time. Down here we also have a number of steps. This is how many steps it's going to take in training. You can change this to any number you want really. I like to keep it at the default and kind of monitor the training, but there is such thing as overtraining, which we'll talk to a little bit later. So if you think you're going to be overtraining, you can feel free to turn this down so the training doesn't go as far. Cool. Now the next thing we need to make is this label map path, as we kind of skipped over this one. So the label map path is where we're going to kind of create a label map. So in our previous videos, you might remember we had to find a path to a label map. So we're going to make our own. So I have another copy of a label map I've already prepared, and I'll show you how we use it. So let me paste it in this same directory. Let me paste it. You can either call it label_map or just label map, but the important part is the pbtxt on the end. And you'll see that a label map is basically going to look like this. So for every item or object we want to detect in our model, you're going to have a new item block, kind of like a little code block right here. So in this case, this ID and name has to be the same as the ID and name that we had in our generate TF record. So you'll see here blue brick to 1, red brick to 2, green brick to 3. So in our label map, you also want to do blue brick 1, red brick 2, green brick 3. You want it to be the same, just like that. Then again, if you have more, just add more item blocks, just like this. Or if you have less, go ahead and remove one. And again, I'll be having this example label map on my GitHub also. So now that we have this, we also want the path to here. So let's copy the path again. And now we're going to put it in our config file. So where we had the label map path, as you can probably guess, we're going to put the path to our label map. So there's ours, and this is going to be the same on both. Okay, cool. Now we have everything we need to start training on our local PC. This also means we're ready to technically train on Google Colab too, but since I'm already in this environment, we're just going to continue from here, and then we'll kind of switch over and go backwards a little bit and train on Google Colab. So if you want to skip to seeing that, I'll put a timestamp somewhere, or again in the chapters in the description. So now to get training, I'll have a command we're going to use. And I can put this command written out in the GitHub also, if that makes it easier. So we're going to be using this command I'm currently copying over. All right. So we're running Python model main tf2.py, which is a file in this object detection directory that we're in. And then you have to choose the pipeline config path. So the config is this file that we just edited. And this is the copy that we had made that we were editing. So this copy is right here, which is also underneath our object detection. So if you have it somewhere else, just make sure you change the path. But since we're in the same directory, I just have it straight up directly to that config file. For the model directory, this is where it's going to start putting training checkpoints. So I have to put it in a training folder. You don't have to make the training folder ahead of time. It'll make a training automatically for us. And then this is just going to log standard errors for us. So that's just good to have. And with that, we should be good to go. Now, I'll warn you, this will take a while to start. Oh, and we already ran into an error. So let's see what our error was. Failed to open our label map. Okay. So I had a feeling that these paths may be a little problematic. So let's go back to our paths. And it says it can't find the label map, which is fine. Let's make sure our label map is actually in the right place. So we put it here, which is under object detection. Okay. Let's get rid of this then. We're going to do it both in here. And I think because we're in the same directory, it should be okay. And I'm actually going to do that for these other directories we had too. Again, this may be different depending on where you have your own things. So I recommend just trying this out and seeing how it goes. Okay, let's try it this time. It might get mad at me for removing those other paths now, but I guess we'll have to find out. So far it looks good. All right, I think we're good this time. So you'll see there's going to start being all sorts of crazy text that starts going on. And you may see some warnings and even errors, but as long as it keeps moving, we should be okay. And again, this is going to take some time to even start training. As you can see, we have a new error there, or warning. I'm actually going to open up my task manager as we might be able to start seeing how intensive this gets on our system. But I think for the moment, I'm going to leave it here and come back to you guys once it actually starts training, because again, this can take a few minutes. Okay, it looks like our training has actually started. So you can see down here, you'll start getting these big blocks with like loss localization, classification, and the number we're really paying attention to is this one right here, the classification loss. This is kind of like how good we're getting to actually being able to detect our training images in models. So you can see my CPU and memory has started to kick up, and we're using a pretty high percentage of my RAM and most of my CPU. For that batch size, we might have been able to kick it up to 4. But again, this is why I don't like doing it on my PC, because I basically can't do anything else on my computer while I'm training because everything gets so slow, which is why I like Google Colab, which we'll show in a minute. But over time, you'll see more of these steps show up. And don't worry if you think it's frozen. These steps only show up about, I think it's every 100 steps. So you'll see after some more time, we'll get like step 200, or it might jump up to 500. And we'll be checking this classification loss. So while we wait for that, we're also going to bring up another tool that we can use with this. So this is just another terminal, and this is Anaconda in the same base environment I'm using for Anaconda. So you'll see down here I have model tutorial. So this is using the same area, and you can see actually we just got a new step. So you can see that loss classification loss is now down to 0.6, which is great. So we're actually going to cd into the directory our project's in. So we're gonna go, I gotta remember everything is now. Yeah, I'm in here, PyCharm projects, and then I called this, I have a lot of different ones of these. Model tutorial, here we go. And then this is where we do our models, research, object detection, there we go. And now we're going to use Tensorboard, and I actually don't remember the command for it. So what we're going to do is that we're going to do a little sneak peek of Google Colab real quick. And we're going to grab this, don't mind me, we'll come back there in a second. And in this terminal, we're going to run this command, which is Tensorboard. And what this does is it actually launches like a little mini web app where we can more visually see our training. If Tensorboard, the command, doesn't work for you, make sure you're in the same environment that we're doing all this other code and work in. And B, you can try doing pip install Tensorboard if that still doesn't work. Here, let's look. So Tensorboard 2.10.1 at localhost 6000. Awesome. So we're going to copy this. And if we go to that directory, you can see a little web app has started. And you can see it actually doesn't have anything to show yet, as we need to wait for some checkpoints and more training to happen. So if we go over here, you can actually see our training folder has appeared now, and some things have started showing up in it. So right now we only have one checkpoint, and eventually we'll get more as this training continues. And once we get more, we should be able to refresh this page, but it looks like we need some more. So we'll let that run for a little bit. Or actually, we just got a new one. So you can see kind of stagnated a little bit, but that might be enough for Tensorboard. Let's find out. Nope, not yet. Okay. Log directory training train. Yeah, I think it just needs some more. So we'll wait on that for a second, and then we can come back. Or you know what? Actually, we'll be able to view it on Google Colab too. We'll just run while we're doing that. All right, cool. So let's switch over to Google Colab so we can see how to do it over there. All right, so welcome to Google Colab. I'll have this file in my GitHub repository also, so you can use this. This code is very copy pasta from a lot of other repos and even the official TensorFlow. I've trimmed this one down and edited it into a way where I like it, but you can always feel free to use other ones that are out there. So if you've never used Google Colab, it's kind of like running little code blocks one at a time. So the first thing we can do is connect to a runtime up here. So we need to get access to some CPU cores, a GPU, and RAM. And we're still initializing now. We're connected. And now you can see we have some stats over here. So like we get 12 gigs of RAM to play with, which is pretty nice. And we have a GPU to use, which is also very nice. So let's close this for the moment. And over here in runtime, we're just going to make sure that under change runtime type, that we're under GPU. That's just going to make sure we're fully utilizing the resources we have. All right. So now to get this started, whenever you open Google Colab, you're going to have to rerun the things you've had before. Because we kind of have to, this is like setting up a new environment every time almost. So what we need to do is that we need to go through these code blocks one by one and get TensorFlow installed on here. Fortunately for us, it's pretty quick. We have 4 cells we need to do. So what we're going to do, we're going to run each of these. And you can see if you click play, it'll start doing all this. And what I'm going to do, I'm going to queue up these next ones. A lot of this is very similar to what we did in the first 2 tutorials, or in the first one actually, where you download the GitHub repo and TensorFlow itself. So that one's running. While it's running, I'm going to queue up the next one and do it for this one too. So these will run once the others are done. Okay, looks like those initial setups are done. So we'll just go back and verify that nothing broke. You'll normally get this error. This is okay. Don't worry about it. These 2 looks like that worked. And these ones run the tests that we also ran in that first tutorial. It's the same thing that happened. We're just making sure it's installed correctly over here on Google Colab. So looks like all 24 tests ran. So that's cool. All right. So now we get to pulling in our data. So we're going to use something called Kaggle, which is like a data or a data set website. And so I've created a data set already that we can use, and you can make your own too. So in my data set, I have my test images, including all the XMLs in there, the train. I have some files in there because we're going to need to use these too. I don't think we actually need the XML to CSV anymore, but we're going to bring those with us. So I'm bringing the TF record, our label map, and then our 2 CSV files. So if you want to create your own, you can make an account on Kaggle. It's free. You just go to create and then a new data set, and then you can just drop all your files in here and you give it a name, and that's really all there is to it. So if you make your own or if you want to use mine, that's all we need. The only other thing we need from Kaggle is that you need an API token key so that you can connect to it from Google Colab. So we're up here in the corner. We're going to go to account. Make sure, if you end up on profile, just make sure you're on account. And then we're going to want to do create new API token. And then it's going to save a file for us. And in here, I'm going to show you my key. Don't worry, I'll get rid of mine. So we need these 2 pieces of, okay, thank you VS Code. We need these 2 pieces of information, your username and your API key, which we're going to need in a moment. So that's all we need from Kaggle. Well, we might need the name of the repo we want, but we'll do that in a second. So we're going to run this block. And as you can see in my notes, this step for some reason fails usually. You still need to run it. It'll say it fails, but I think it actually works. It's kind of weird. You'll usually get some sort of like a setup error. I wonder if it's working today. Okay, no, there's an error. Let's see what it says. Yeah, there's usually an LXML error. So yeah, don't worry if you see this. It took me forever, but it turns out you can just continue. For whatever reason, it's fine. So yeah, let's just go on from that. So now here is where you put in that information we just got. So put your username in here, and then your key. So let me grab my key, and I'm going to toss that in here. Get rid of the brackets. Whoops. So we're like that. And again, I'm going to delete my key, so don't try to use mine. Make sure you put your own key in there. And then we're going to run this. This is just kind of setting variables for our system. And now we're going to use Kaggle to download a data set. So we're downloading my data set. So if you don't want to use mine, and you probably don't, you put in the username of the person who made it. So that's probably yours. And then you put in the name of the actual data set. So over here, if I go to my data set, it should have the name in here. Or maybe not. I think it's always just going to be the name, and then it put dashes in it. Yeah. That's just how it works. Trust me on that. So yeah, if you have your own, if you had something like macaroni detection, you would do macaroni dash detection. Or if you just had the one word macaroni, then it would be like that. But when you do it, oops, just make sure it's the username of the person, not your, well, yes, it's probably your username, and then the name of the data set. So we're going to run that. And I have a list command here just to make sure that we actually download it. Because it's going to download it and then unzip it. So you can see in our directory, we have all the files we had in there. So we have the generate TF record, our train, our test, our label map, and our CSVs. And we also have some things in here that come with Google Colab. So that's cool. Nice. So now we're going to get our generate TF records. And if you don't want to put those files in like the generate TF record and like the test labels, if you don't want to do that through Kaggle, you can always download it through your Google Drive, or you can upload it. If you go over here, you can actually upload a file, or you can connect your Google Drive and upload them that way. I just thought it was easy since I had to make a data set anyways. I figured I just put all the files in there. So that's just what we're doing. So for our purposes, we're just going to have it come from our data set. So this is the same stuff that we just did on the local PC, if you were watching that. So it's the same command, generate TF record, your train labels, the directory, train.record, test.record. So we're going to run this, and this is just going to create both of that train.record and test.record. That might take a second. And there we go. You can see created train.record and test.record under the content directory. And now we're just going to set these variables too. Again, this might change for you if you have your things named differently, but they're probably the same. Especially if your label map is a label underscore map. Make sure it's like that. But again, these are just like setting variables. So all we're doing is just saying that this path is equal to train.record, this path is test.record, and our label map path is labelmap.pbtxt. And again, this one came from our data set that we downloaded. All right, now we're going to configure training. And so this is where we can actually be a little bit more liberal with that batch size. So since we're using an actual GPU this time, I'm going to keep it at 16, and you'll see that the training should progress much faster. For them, they have 8,000 steps and 1,000 eval steps. I like these. These are all good to me. I'm fine with that. We'll use that. So we're going to run that. Make sure you run these, even though it looks like there's not much code happening. These are setting values for those variables. So in here, we're now downloading the model. So we also did that on our local machine. It's the same thing. We just copy and paste the model from the model zoo. This is the same model we were using. So if you're using a different model, just make sure you're pasting in the correct link. And then the same thing here for the name. So we're going to run that. It might take a moment. So we download the model and we saved it. Now we unzipped it. Very nice. So now we do the same thing we also did, where our fine-tuned checkpoint is now this new checkpoint that we have. So we're going to run that. I like the Google Colab method because everything's already set up and you can kind of just click a run for most of these. All right. So now we have to do another wget. We're going to grab that config file from that object detection configs tf2. If you remember, we did that with the local machine. This is like the same place, except we're just directly grabbing that file from the GitHub source. So it's the same thing we did, just grabbing the one file. And now we're just saying that our path is just that name. So again, you might just need to update these names if you're using a different model. Otherwise, same idea. And now all this does is just updates the file with these variables that we've been setting. So you can see in here, config, resub. So we're editing it. So the fine-tune checkpoint is now our new variables that we made. So we're just going to run that. And this just shows us the file afterwards, just kind of to confirm that everything was updated. So you can see our input paths, label maps are all good now. All right. So now last thing, we just have to say the model directory and the config path. This one you can keep the same, and this one I'm also going to keep the same. Again, you can feel free to play with these settings, but doing it this way should work for us. So now we're going to run Tensorboard before we train. So you can see this is what Tensorboard normally looks like. You know, our actual Tensorboard from before might be working now. Maybe not. It's a little finicky on local machine, I've noticed. So don't feel afraid if it's not working for you. You can still monitor the progress. And here you can see we got some more steps, but it is going quite slow on a local machine. But don't be afraid if this doesn't work. It is kind of finicky, but on here it should work. So we're actually going to run Tensorboard before we start the training, because otherwise we won't be able to run the second code block. So you can see this is what it normally looks like. It'll show you the different graphs we have for classification. This is from a previous run that I've done. So we're going to run this, and it's going to basically start the web server inside of this code block, which is pretty cool. And this might take a second to load. Come look at that in a moment. Again, I hope it works. Tensorboard can be really finicky. It's kind of annoying. All right. So now this is the actual training step or command that we used. It's the same one we used for local PC, just with all the paths set up. And all we got to do now is run this. We should be good to go. And we can look at what comes next. You can see Tensorboard loaded. So we're going to get the same message until we get some more training done. So that's why I like to run this one first, because we can just refresh it right here. So this, again, will take a few minutes to go. So I'll meet you guys back when that is ready. Okay, I forgot to record the transition of it actually loading here, but you can see that we're now getting the training steps coming in. So this is the same type of output that we were getting with our local machine training. So that's great. So now it's basically a waiting game. We might be able to start Tensorboard. Let's take a look. I'm assuming it's probably going to tell us no. Oh, no, here we go. All right, cool. So it doesn't have the graphs yet, but it will show us what pictures we're looking at, which I think is really cool. So these are the samples that it's currently using to train, which I just think is kind of neat to look at. But otherwise, the next step is to just wait. You can see we already got a new one in down here. So we're in from 1 to 0.5, which is a pretty big jump. If you click up here, you can actually see our usage. You can see we got 15 gigs of GPU RAM, or VRAM really, which is nice. So this is much better than running it on local. We're already going a lot faster, you know, for comparison. So let's see how our local machine's doing. So you can see on local machines jumping back and forth. So it was going down 0.4, 0.4, 0.3, 0.5, 0.4, and then up to back to 0.9. So it's going to take a while on PC, and I'm actually going to stop it on here because I already have a model trained. If it will let me stop it, you can do Control-C to stop it, or sometimes it gets a little stuck. Oh, there it goes. If that doesn't work, you can just close the terminal up here. Okay, well, stopped, but you can close it, and that will also close the session, so that's good. This one, we'll let it run for a moment, actually, just so I can show you the next. Actually, I think I can run it now. Let's run it now, yeah. So the next step is going to be the same for both local PC and Google Colab, just in their respective environments. So we need to actually export our model inference graph. So we'll let this one run for a few more seconds. Sorry. And let's go back over here because again, this is gonna work the same. So now just to export it, we're just gonna use this command. I'm gonna paste in. And let me get rid of these things over here. And again, I'll have these commands online. So in this one, we're just running this exporter script, and we're passing in the train checkpoint, which comes from that training folder that automatically got made. We're giving it the config file that we made. And I think we're going to actually have to change that because I believe our file is not in training. And then our output directory, so this means it's going to save it to a folder called inference graph. And you know what, before I forget, let's update this command right here because I got to get rid of that training. There we go. And so let's run this. And I believe this command takes a minute too because it basically got to spin up the stuff again. We'll see if it starts making the inference graph. I think that's what we called it, inference graph folder. Yeah, so we'll give that a second. So this is just it's kind of like compressing all of it into our new model. And you'll see the output format of it is very similar to the model that you would normally download, like our efficient D0, our faster RCNN. We get a format very similar to those. So this is still going. Let's take a look at Google Colab. Oh yeah, so you can see with Google Colab, our training is already much more efficient. We're going from 1 to 0.5 to 0.3. I don't think I mentioned this, but when you train, you generally want it to get down to 0.1, 0.05 if you can. If you get down to 0.1 and it kind of stays at 0.1 for a while, that's when you should stop training. You don't want it to get too low, otherwise you'll overtrain it, which means it'll get really good at detecting it, but only in the pictures that you use to detect it. So it won't be good at doing it in like different situations. It gets too used to the exact photos that you used. So that's why you want to stop it between like 0.1 and 0.05. Let's see if Tensorboard will show us all those graphs yet. Yeah, looks like they're here. If they load in. Yeah, so you can see we only have like 3 or 4 points on here, but like you saw when I first pulled this up, you'll eventually get kind of like this downward like log graph almost. And once it kind of starts to plateau, that's when you should cut it off. But again, we're just going to end it early here since I already have a trained model of this and we can still use it. So let's stop it here. Well, that stops. We'll look over here. So we'll see that it finished. So now we have a new folder over here, inference graph, and you can see how it looks just like this pre-trained model. We have a checkpoint folder, a saved model folder, pipeline config, and the big thing that we want is the saved model, and then down in here we have saved model.pb, and you might recognize that from our webcam detection. It's the same thing. So let's go to Google Colab. Looks like this is still stopping. It might take a second. It doesn't like to stop. There it goes. Okay, all done. Cool. So now this is going to be the same thing. We're just going to output it to something called an inference graph. So we're going to do the same thing, run it over here. And when we're done with this, I'll show you guys how we can use our new model to detect images in photos, or detect objects in images and on webcam, just like how we did in the first and second tutorial. Okay, looks like our graph has finished exporting, which is nice. So now we're going to download it. You can download it here, that's straight to your local computer, because you're probably going to be using it on your local computer after you train it. So I put some blocks in here that lets us do it. Doing this, we'll just zip that folder that we made. So like on our local PC, we had that folder. The same folder structure got generated in here. So now we're just going to zip it up and download it. And you can see we have this little progress bar. This can also take some time depending on how big the model is, especially if there's like the more images, the bigger the model itself is going to be. So that can take some time. I also have this optional code block in here where you can connect your Google Drive and copy the training data. As I can show you guys, you can actually, remember when you set that fine-tune checkpoint? You can set that fine-tune checkpoint to a checkpoint from your training. So if you're, say, training it on your local computer, but you need to stop because you have to do some other work, you can stop the training and start it again later by just passing in the most recent checkpoint. So, for example, so in here, the fine-tune checkpoint is originally the checkpoint from that efficient det checkpoint 0, so from that one that we downloaded, right? But from our new one, when we were training it, we get training, and then we get new checkpoints. So you can pass in the most recent one you have. So instead of it being the efficient det, you would say from the training folder, from the training folder, grab checkpoint 2, and you could put that in right there. So this training folder also gets created on Google Colab. So that's why I give you that option to copy that training folder to your Google Drive, because you could always pull it back in later. So this is very useful if you want to start training again, if you have to stop for some reason. So let's check this out. Still zipping that model. Here we go. So now you can see it'll let us download it. I'm actually not going to download it because I already have one. So we're going to close that. And let's go back to this project. And I'm just going to copy in a model I've already created because I trained one previously. So we're going to paste it in here into our object detection and copy pasta. And so these are just some of like the files in here. It doesn't really know what to do with them. So now let's see. So let's detect it. Let's test it on some images. I can't use my webcam right now because for some reason OBS gets sad if I check. Well, TensorFlow doesn't like it if I have OBS running with my webcam sometimes. So we're just going to test it on images, but you can do it the same way we did in the second tutorial with our new model, and I'll show you how to do it. So we're going to open up our detect from images, and we need to give it some test images actually, because the test images that we used before were just for random things. So now what we want to use is some that would actually be related to our model. So pictures of Legos in my case. So what we want to do, let's open up the test images folder. I'm actually going to open it in File Explorer. Test images, and I have a folder already called Lego test images, and you can see I have a couple pictures in here. And as a reminder, like I said, the model I trained did not have nearly enough pictures in it, and I did not train it for enough time. So we're going to see some kind of funky results, but you'll see that it does detect some of the Legos, which is cool. So we have this in the Lego test images. All right. And now we're going to use this command. We're going to take, well, really, we're only going to use this beginning part of this command. Yeah, let's take this. So we're the script, and then the model path is now going to be our new model. So let's take a look at it. So we need to get this saved model. Well, technically we need the saved model folder. So we need, new model / content / inference graph / saved model. There we go. And now our label map is just going to be that label map we made. Mine is in the same directory as the object detection, like in here, so I don't need any more paths in front of it. And now we need the test images. So we're going to say, test images, and then I have the Lego test images like that, and we're going to hit run. And that might take a moment. And while we're doing that, actually, I'm going to open up that directory again. It's a little bit easier to see. I actually have it open already. So that's still running. Depending on how many pictures you have in there, it'll take longer to run. So we have it in our, we should have an output. Here it is, outputs, and we can see it's done. So let's take a review. So look at that, a red Lego brick. That's pretty good, right? 99% confident, I'd say so. You can see it gets a, depending on the size of the image, they get a little overlap. You can see it found the green brick. It definitely found the red brick. It thinks this black one is something. and there's some others in there. Again, this is a result of me under training it, but you can see it's definitely working for the ones it knows. Let's check this last one. This is a green brick. The label just gets cut off because of the image size. But yeah, that works pretty well for not training it for super long. Again, I trained this the other day, but not enough images and not for enough time. But yeah, our model works, which is great, and yours will probably work even better if you train it for a long time. And yeah, so we can do this with the webcam too. The webcam is going to be the same way with this type of command. So from the webcam one, you just have to pass in the file we're using, which is the webcam detection script, and the model. So the model will be the same thing that we said for this one. Where's that command? So we said the model was that new model, content, inference graph, saved model, and the label map will also be that new label map we made. And then that's all we need for that one. So yeah, that would work on our webcam, but I know the webcam's not going to work for me right now, but it should work the same way, and we saw it work with the images. So yeah. But yeah, it's pretty cool. That's all it is to make a model. And I know I say that after this is probably like an hour of recording or so by now. But yeah, let me know if you have any questions or problems in the comments. I'm always down to help people out in the comments. And if you guys help out each other, I can make a list in the comments. I'll make a pinned comment for common fixes, as you know, somebody will always find a new error that shows up, as I know I always do when I make stuff like this. But otherwise, thank you for watching, and I hope to see you in the next one. See ya.